when the planet turned into an ocean. There was a time when rain never stopped falling, not for days or years, but for ages beyond memory. And when it finally ended, the planet was unrecognizable. Today, water defines Earth so completely that it feels inevitable, but nothing about its presence was guaranteed. Oceans cover most of the surface, regulate climate, and quietly sustain every living system we know. Yet in Earth's earliest history, water existed only as a threat or a vapor, appearing briefly before vanishing again. Understanding how Earth became a water world matters now, because this balance between fire and fluid still determines whether a planet can remain alive. The transition from molten surface to liquid ocean was not a gentle gift. It was earned through endurance on a planetary scale. After the moon settled into orbit, Earth began to cool, but not gently. Heat escaped in waves, through massive volcanic eruptions and constant surface renewal. Gases poured from the interior, building a thick, toxic atmosphere rich in steam, carbon dioxide, and sulfur compounds. There was no blue sky above, only dense clouds that trapped heat and refused to clear. The pressure at the surface would have been crushing, far beyond anything we experience today. And the air itself was a hostile barrier between the planet and the void of space. Water was already present, locked inside minerals and delivered by icy bodies striking the surface. But the temperature remained too high for it to stay. Any liquid that formed boiled away almost instantly, rising into the atmosphere where it joined an ever-thickening veil of vapor. The planet was preparing for oceans without yet being able to hold them. What followed was a transformation driven by patience rather than force. As cooling continued, the atmosphere reached a tipping point where steam could finally condense. Clouds thickened, pressure increased, and the sky darkened further. Then, slowly at first, rain began to fall, not as weather, but as a planetary event. This was the beginning of Earth's longest storm, and it would change everything. The rain did not arrive gently or briefly. It fell with relentless force, driven by gravity and fed by an atmosphere overloaded with water vapor. For thousands, possibly millions of years, the surface was battered by continuous downpours that reshaped the planet grain by grain. Lava fields hissed and cracked as water struck molten rock, releasing steam in violent bursts that thickened the clouds even further. Rivers formed before continents had names, carving temporary paths across unstable crust that shifted beneath them. Water gathered in every low point, pooling, spreading, and merging as the surface slowly cooled enough to hold it. Each drop carried heat away from the planet, acting as a cooling system that reinforced the process already underway. The more rain fell, the more stable liquid water became. This self-reinforcing cycle was the engine behind the transformation, turning what began as scattered pools into a connected, planet-spanning body of water. As oceans began to take shape, they were nothing like the calm blue expanses we know today. They were hot, acidic, and constantly stirred by volcanic activity below and impacts from above. Meteorites slammed into the surface, sending towering plumes of steam skyward and briefly boiling entire regions of water away. But each time, the oceans returned, deeper and more resilient than before. The atmosphere responded as well. Carbon dioxide dissolved into the growing seas, slowly reducing the greenhouse effect that had once trapped heat near the surface. This feedback loop allowed temperatures to drop further, locking liquid water into place. For the first time, Earth achieved a stable balance between heat, air, and ocean. The chemistry of the atmosphere and the chemistry of the ocean had become entangled, each one moderating the other in a partnership that would persist for billions of years. What had once been a hostile, burning surface was now covered by a global system capable of regulating itself. The planet had crossed another threshold. Fire no longer ruled alone. And within these restless oceans, something unexpected was quietly beginning to take shape. Beneath the surface of these young oceans, the planet remained anything but calm. Heat from Earth's interior continued to rise, escaping through fractures in the crust and along vast volcanic chains hidden below the water. Where molten rock met seawater, violent chemical reactions unfolded, releasing energy and rare compounds into surrounding depths. These were not peaceful environments, but they were stable enough to persist. The oceans became Earth's great experiment. They absorbed impacts, redistributed heat, and dissolved minerals from a newly formed crust. Every interaction added complexity. Salts accumulated. Chemical gradients formed. Energy flowed through water in ways it never could through solid rock alone. The surface world still faced bombardment from space, but now the ocean softened each blow, protecting what lay beneath. Depth itself became a form of shelter, shielding the lower reaches from the worst disruptions above. At the same time, the planet's crust continued to evolve. Plates shifted slowly across the mantle, driven by heat and pressure below. New seafloor formed volcanic ridges, while older crust sank back into the interior, recycling material through a process that would shape Earth for billions of years. This constant renewal kept the oceans chemically active, preventing stagnation and maintaining balance. Each cycle introduced new elements into water, while removing others, creating an ever-shifting chemical landscape that rewarded adaptability over permanence. What mattered most was time. For the first time, Earth could change gradually instead of catastrophically. Conditions held long enough for patterns to repeat and reactions to continue without interruption. Energy, water, and chemistry were now linked in a continuous cycle that resisted collapse. The oceans were no longer just water. They were systems, dynamic and restless, capable of sustaining complexity without destroying it. And as stability increased, the line between non-living chemistry and something more began to blur. Earth had not yet discovered life, but it had finally created the conditions where life could be possible. The turning point was not marked by a single moment, but by endurance. The ocean stayed. They did not boil away, did not vanish into space, and did not freeze into silence. They persisted through impacts, eruptions, and constant internal motion, acting as Earth's stabilizing memory. Every cycle of evaporation and rainfall, every interaction between rock and water, reinforced a balance the planet had never known before. This stability transformed Earth in ways that reached far beyond the surface. Heat was redistributed globally instead of building up in isolated regions. Chemical reactions slowed just enough to become repeatable. Complex molecules could form, break apart, and form again without being erased instantly. The planet had learned how to sustain processes instead of constantly resetting them. In this way, the ocean became more than a feature of the landscape. It became the medium through which Earth could experiment with its own future. What makes this moment so powerful is how ordinary it feels today. Oceans seem permanent, inevitable, almost passive. But their existence was once fragile, hanging on the narrow edge between fire and ice. Earth did not gain its seas because it was destined to. It gained them because countless conditions aligned just long enough to hold. From space, the planet would now look different. Dark landmasses broken by vast reflective surfaces. Clouds cycling water between sky and sea. A world no longer defined by molten chaos, but by motion held in balance. This was the foundation for everything that would follow. The oceans did not create life, but they created patience. And patience, more than anything else, is what the universe had been denying Earth until now. So, what do you think? Are we repeating the same mistake again? When the